Assalamualaikum and good day. In this video, I'm going to explain to you example A5. So you have this block diagram here where you have a system plan. We have 2s plus 3 over s cubed plus 3s squared plus 2s. And then from this, we can find the characteristic equations. We know that the closed loop system is given by g over 1 plus gh. So we take the denominator 1 plus gh equals to 0 as the characteristic equation. And we have this polynomial as our characteristic equation. And we can find the stability of the system without knowing the location of poles on the S-plane by putting all the polynomial here in the Routh table. And we have the coefficient of this polynomial. We have 1, 3, 2k plus 2, and 6. And then we insert it into the first two rows of the Routh table. We have 1, 3, 2k plus 2, and 6 over here. And then we can calculate the value for the next row, where we have 3 multiplied by 2k plus 2, and then we minus 1 multiplied by 6k, and then we divide by 3. So what we have is we have the value of S1 over here equals to 2. And then we proceed to the next row, where we have 2 multiplied by 6k, and then we minus 3 multiplied by 0, and then we divide by 2. What we get is we have 6k. So to evaluate the stability of the system, we see if there is a sign change on the first column is this Routh table over here. So we have 1, 3, 2, and 6k. So this is positive, positive, positive. And in order for the system remain stable, we must have 6k greater than 0. So 6k greater than 0, we have k greater than 0. Alright? And what does it mean? It means that when we have for whatever values of k, the system will remain stable. So I can show you what happened in this example using MATLAB. So we have here example A5 over here. So we have GA5, TF. I use TF because in this example, the polynomial are given in the characteristic equation. If these characteristic equation, the poles are given, so I will use ZPK. Alright? And in this case, we have 2, and then we have s plus 3 over s squared plus 3s plus 2. And then I find the root locus of this system. So what we have is we have the root locus for this system to be like this. So when I double click on the root locus, you can see here when there is no k introduced in the block diagram, so means k equals to 0 or k is not exist. What we have is we have the poles located on the left hand side of the S-plane. So when we introduce k, means we increase the value of k. What we have is actually the k value increasing until we increase the value of k until it becomes infinity. So here the gain become infinity. What we have is actually the poles the poles are still located on the left hand side of the S-plane. When the pole is located on the left hand side of the S-plane, means that the system is stable. So in this example, the system will remain stable for all the value of k when we increase from k equals to 0 until k equals to infinity. So the system will remain stable, and it is good to know that the system is stable. So I hope you understand this example, and I will show you another example in the next video. please re-watch the video until you understand fully on the Routh table and the relationship on this Routh table and the location of poles that I have explained using the Rod-Lucas plot here. Until then, thank you very much for your attention. See you. Bye-bye.